Vamos a empezar la sesión. Las dos pláticas van a ser en inglés. Si alguien necesita la traducción simultánea, todavía estamos a tiempo para que puedan ir por los audífonos, por el traductor. La idea es tener unas pláticas aproximadamente 20, máximo 25 minutos, para dejar unos 5 minutos para preguntas al final de la presentación. La información acerca de los conferencistas la daré un poco antes de que les dé la palabra para que den sus conferencias. ¿Sí? Bueno, vamos a empezar las conferencias con la primera plática. Está a cargo de la doctora Barbara Ryan. La doctora Barbara Ryan es directora de la Secretaría del Grupo Intergubernamental sobre Observaciones de la Tierra, mejor conocida como el GEO. En este cargo dirige la coordinación de las actividades acerca de básicamente la información para tener mejor información sobre el estado de la cobertura de la tierra en temas como agricultura, biodiversidad, ambiente, ecosistemas, etcétera. Tiene una ingeniería en geología de la Universidad Estatal de Nueva York y tiene 2 maestrías, una en geografía de la Universidad de Denver y un grado de maestría en ingeniería civil de la Universidad de Stanford. Tiene una amplia experiencia profesional, quizá una de las más importantes es que fue cuando estuvo trabajando trabajó en el servicio geológico, pero es una de las impulsoras de hacer que la información de los satélites Landsat sea libre a través de Internet para todos los usuarios que lo quisiéramos platicar. Le voy a dar la palabra a Bárbara sin más para que pueda platicarles 20 minutos, si quieres aquí como platicado o si quieres allá como más. Gracias.
Thank you very much, Muchas gracias, and it's a pleasure to be here at this conference. As that biography said, I spent a fair amount of my career, 34 years, with the U.S. Geological Survey in the United States, and it was in that position, particularly the last 10 years or so, where we had a very strong working relationship with Mexico, particularly with ANEHI, because I had the responsibility for the cartographic program, and also had responsibility for the Landsat program. And so within the Geological Survey, we were trying to bring imagery and geospatial information or cadastral information closer together. And even within one agency, it was very hard. So YGEO, the Group on Earth Observations, wants to forge a strong partnership with UN GGIM is to in fact bring all Earth observations information together, not just that which was collected from space, but also what was collected on the ground. And so, let's see, I think we're going to have to do, that's the first slide. So for this particular session, we'll talk about imagery and the role that plays in the Group on Earth Observations. But I do want to say at the outset, we are not just about, the Group on Earth Observations is not just about Earth observations from space, it's also ground measurements as well. So for a couple people that may not know, the Group on Earth Observations was started in 2005 with 4 primary objectives: improve and coordinate observation systems, advance broad open data policies and practices, I'll come back to that, foster the increased use of Earth observation data, that's what we have been talking about all day, and then ultimately to build capacity. So when we talk about the Group on Earth Observations, one of the mechanisms it has is to in fact create or build a GIS, a global coordinated, comprehensive and sustained system of observing systems. So this is where you would see, and I'm going to try not to put the laser on you, but you'll see both space-based observations and in situ observations as well in a number of different, we call them societal benefit areas, and they are shown here: agriculture, biodiversity, climate, disasters, ecosystems, health, energy, water, and weather. So how can we bring Earth observations to bear on each one of these societal problems? So here you can see the map of those 90 countries that are in fact GEO members today. We still have some challenges, some in South America, some in Africa, the Middle East, and some Pacific Island states, but we do in fact have 90 member countries. A lot of the Northern Hemisphere, more challenges in the Southern Hemisphere. But I also want to point out this next slide, and while this slide is quite busy, these are the participating organizations that are also members in GEO. So it's member governments that were shown on the first slide, and it's also participating organizations, many of which are represented at this conference this week. And what we would love to see over the next year is that UNGGIM become a participating organization in GEO, because I think it's only when we attend each other's conferences that we can start to forge closer relationships. And then just one other thing, because our governing body in last November had its big meeting down in Brazil, and they said, that's great, you're working with member governments, you're working with participating organizations like those UN organizations, but you need to go farther. You need to bring the private sector into GEO as well. And so if we look at the private sector, it's data providers like Digital Globe and GeoEye and Astrium and all those organizations that are collecting either imagery or in situ measurements. It's those value-added providers, those companies that do something with that geospatial data. And I might actually put the companies we've heard from already today, like Esri or Google, in that category. And then it's also those downstream users, those users in agriculture and energy and health and water. So it's a very broad and diverse private sector out there. But if we do in fact want to ensure that Earth observations are being used for society's problems, then we really need to do a better job of reaching out to the private sector. And I'm happy to say that we'll be working with an organization called Geospatial World, like the World Forum. We're going to be co-hosting that meeting in Geneva next May with that organization that brings a fair number of private sector companies together. So space-based assets, you'll see these satellites, but it's also in situ measurements that are shown here. And so following Mark Reichert's presentation just before about interoperability, what we really are trying to do is interoperate those space-based systems and the observations from those ground-based systems. So these next couple slides, and I'll go through these rather quickly, are just to talk about the applications where we are using imagery, and in some cases high-resolution imagery, which was the subject of this particular session. So what you will see on each of these next slides is a title for the slide. In this case, it's agriculture, it's crop information for decision-making. You will see those organizations, those countries, and or those participating organizations that have come together to work on this particular issue, and then you'll see some results or a graphic that speaks to those results. So that's the format for every single one of the next slides that you're going to see. So on this particular slide, it shows an anomaly correlation for vegetation, and so green shows healthier vegetation than normal, red, yellows or oranges shows less healthy vegetation. And so in this slide, you can see the droughts of 2012, both in the central United States, reaching some parts of Mexico, and then also into Europe, reaching some parts, Russia, reaching some parts of Europe. So biodiversity, again, these companies, and what we're trying to do in this particular area is use Earth observations and do a better job of responding to the Convention on Biological Diversity, that UN organization and that UN convention, to try and do a better job of reducing the loss, increasing biodiversity, stemming the loss of the lack of biodiversity. Carbon assessments, again, I think each of the speakers this morning talked about this impact and the effect that it is having on climate change globally. Certainly cold region monitoring, and that slide that Mark showed about the Netherlands and the fact that we've got increasing melting of the Greenland ice sheet, rising and rising sea levels, and the effect that it causes globally. Disaster information, we work with the International Charter on Space and Major Disasters, and so they are bringing in high-resolution imagery, not only from those government sectors, but government suppliers, but also from the commercial providers that tend to bring higher resolution data to the table. Near real-time warning and response, we're working with, in this case, it happens to be Canada and the United States, and CIAS, the Committee on Earth Observation Satellites. And I do have an animation a little bit later on that talks about the role of imagery in a particular volcano later in the talk. A couple of the presentations this morning have already referred to the migration out of the country areas into the urban areas globally. We've got an effort where higher resolution imagery is being brought to bear on something called global and local urban footprints, and you'll happen to see, this happens to be Manila from 1975, I think, up to the year 2010, with the absolute explosion of global population in that particular city. Advanced land cover products, although this slide doesn't show this part of the world, but just as over lunchtime when the exhibit area opened, I saw that some early work that Canada, the United States, and Mexico had done on coming up with a common algorithm or a common representation of land cover across this entire area of North and Central America was a phenomenal story, and it's that kind of work that we are trying to support and stimulate so that we can not have these disconnects at the national borders. Ecosystem classification and mapping, also saw this happens to be South America and some parts of the Scandinavia, but again, saw a good slide of some work that's being done right in this country at lunchtime. Global forest information systems, so not only middle and low range, low altitude imagery, but high altitude imagery is also being brought to bear by these particular countries. And I might say that all of these slides can be available to you, so don't feel like you have to write down these particular efforts. This slide, I might need some help advancing this slide because for some reason the clicker's not going. So let's see if we can manually advance. Yeah, tools for health and decision making, and so you can see whether it's African dust, and the effect that that has on lungs, but the role that satellite imagery plays in this is critical. And I think for those of you that don't know this, you know, when we talk about the processes in one part of the world affecting another part, I believe there's been some work in the Caribbean where dust coming off the Sahara actually gets into the atmosphere and is now being deposited on coral reefs in the Caribbean, and so they are actually attributing some of the die-offs in the Caribbean to African dust, and you would never think that a system that is east of the Caribbean would actually have an effect back to the west, but it does. More water information happens to be here with changes again in vegetation and the effect that water supply has in that area. And then these are the last couple slides. This happens to be from your partners to the south, Brazil, with their China-Brazil Earth Resources satellite, and the partnership where they are going through a data democratization. So China and Brazil are releasing CBERS data for all of Africa free of charge because of the development issues there. I want to spend just the next couple minutes going back to something that we've alluded to a lot in the presentations already this morning, and that's the importance of broad open data sharing. And I think it's particularly keen for high-resolution imagery. Clearly, for commercial providers, they are selling this imagery, and that business model will probably stay in place for quite a while. But for government agencies where the citizens have in fact paid to launch the satellites, to operate the satellites, to implement the stream gauges, or to put the atmospheric monitoring devices like balloons in the air, then what GEO, the Group on Earth Observations, is advocating is broad, open data policies. We are saying the citizens have already paid for that instrumentation to be put in place, and they shouldn't have to pay again to get the data back from those same observations. And so the infrastructure so in addition to an infrastructure that we are putting in place, we also have an effort called GeoNetcast, where if the internet connectivity is not particularly good, say in Africa, then you can get rather inexpensively direct downlinks of satellite imagery to your particular area. And this is one mechanism to get that data to you. Just a quick graphic on our particular infrastructure, because the data does not come into GEO. The data stays resident with those organizations that own the data. So if you do have archiving capabilities, quality assurance on that data, metadata, so that data can be characterized, much like what Mark talked about in his OGC in the luncheon presentation, then all we are trying to do is expose that data to other users globally. So we are about discovering and accessing that information. And this word interoperability that you heard before is exactly what we are employing. These are all organizations that have their own data sets, their own archives, their own libraries, and rather than asking them to re-register all of that data in our infrastructure, we are just saying, let's work on an interoperability agreement so that our users could at least discover, hopefully access your information, and similarly, this will expose your data to a much larger audience than would have seen it before. The result of that shows the interoperability strategy went into place in about 2011 or 2012, and you can see that we now have close to 14 million data assets that are both discoverable and many of them are accessible. So as soon as the interoperability strategy went into place, then the data assets went way up. And that's where we've got some data that is just wide open for everyone, and it happens to be called Data Core. I do just want to show you one slide on the Landsat story, because as soon as the United States changed its policy to release the data over the web, this is what happened. For 40 years, the first Landsat satellite was launched in 1972, and you can see that at the best year of sales, which was 2001, 53 scenes a day were sold, and as soon as the data was delivered over the web, it jumped up 2 orders of magnitude. 5,700 scenes a day are downloaded over the web for free, and so it's close to 12 million scenes right now. Canada saw the same thing, and I actually, in one of the presentations today from ANEHI, as soon as the strategy changed, I think they saw a similar 2 order of magnitude increase. And so what we are arguing is the economic value is not in selling the data. The true economic value is what you do with the data. So it's goods and services, and it's an economic growth once you remove that barrier of data sales. And I think, and this is actually the last slide. It takes us back to some high-resolution imagery. This happens to be INSAR data from NVSAT. And I think we've got to switch to the animation so you can see it. We're looking at time along the bottom of the graph. The colors are going to show pressure as it's building up in the volcano. The colors are actually deformation. How is the shape of the volcano changing as the pressure builds? And it's that black and white line on the right-hand side. So you can see time elapsing, pressure building up, and deformation occurring. And so, of course, what we're arguing is, wouldn't it be wonderful if not only this data was broadly and freely available, but can you imagine all of the disasters around the world? And it would be phenomenal if we could get a 24-month lead time on many of those disasters. But it's going to take integrated information, broadly shared globally, to address issues like that. And I think that's my last slide. Thank you very much.
Gracias, Bárbara. Tenemos tiempo para un par de preguntas. Sí, por favor.
Thank you, Barbara, for your resume of the GEO and GEOS activities. My question is it possible to know which is the annual budget of GEO and GEOS, and which is the most important institution or member state that participate in this budget, please? Thank you.
You know, I said we are not a UN organization, so there's no mandatory funding scheme. So we only work off voluntary contributions to our trust fund. And there are, of those 90 member countries, about 20% make a contribution to the trust fund. So 80% do not financially contribute. But as much as the financial contributions are welcomed, those contributions to the work plan are what ultimately build this global Earth observation system. So what we are arguing is that even for the poorest country, if you cannot make a financial contribution, hopefully you could contribute some of your work that you are doing anyway, but exposing it to a greater community through GEOS. The 4 largest contributors financially are Japan, the United States, the European Commission, and both South Africa and China come in that 4th or 5th slot.
¿Otra pregunta? De todas maneras, si tenemos tiempo, cuando termine la presentación de Michael, podríamos regresar a hacer alguna pregunta con los panelistas. Muchísimas gracias, Bárbara. Bueno, nuestro siguiente conferencista es el doctor Matthias Schramm. Él es, como formación, maestro en ciencias, en geodesia y geoinformática, y tiene también un doctorado en la Universidad de Leibniz en Hannover. Todo lo que he estado trabajando es básicamente con procesamiento de imagen satélite en términos de estudio de la dinámica de la cubierta del suelo y de la mejor estimación de inventarios. Tiene varios trabajos sobre humedales, está trabajando en los proyectos RED para reducción de emisiones por deforestación y degradación de suelos, y la plática de ahora tiene que ver básicamente con esto del procesamiento de las imágenes. Por favor, doctor.
Thank you for this introduction. I want to talk today. I want to talk today about a project we are doing here in Mexico, actually, which is using high and highest resolution satellite images. It's called Reinforcing Wet Readiness in Mexico. This is a project which is funded by parts of the United Nations, and they chose Mexico because it's biodiversity, and when we can handle all the different ecoregions here in Mexico, then most likely we can handle all the 80% of all the ecoregions in the world. So this project is a kind of an international project. It has many international and also national partners. The most important here are the Norwegian government, because they are the founders of this project, but also national commissions like CONAFOR are here really important parts, because in this case CONAFOR is a partner who is responsible for the results, and also FAO or UNDP and Español PNUD are working with this project here as a technical assistance and supporters. The most important goals of this project are, there are three most important goals. The technical part is the implementation of an MRV system. MRV stands here for measurement, reporting, and verification, because the Kyoto Protocol was ending at the end of 2012. The United Nations needed a new project for this, and this is a RED project. RED stands for reduction of emissions due to deforestation and degradation. Another part is the educational component. We want to promote Mexico to a center of excellence in this RED topic, and we want to help Mexico to be a kind of seed in a South-South cooperation, that Mexico can help after that other countries in Latin America to do the same stuff. A third, more political component is the analysis of actually implemented incentives within the forestry sector. We want to see if these incentives are enough, if they are maybe going in the wrong direction, if we need to do more. And if we can go on with these incentives, or if we have to change our direction. This is a theory. In practice, that means at first we have to make several changes in the legal frameworks in Mexico to ensure the success of our projects. We also have to build up a kind of geoinformation system, and to make sure that national commissions like, for instance, CONAFOR, CONABIO, INEGI, are available to put their stuff in these geoinformation systems, and also that they are using it. A second goal is we have to make much progress in these MRV systems for the RED program, and we also have to build up a kind of draft for a national strategy for the time when this project is over, because this project will not go forever, but the result has to be worked here in Mexico all the time. A third one is we have to make an impulse for a kind of public policy model. We only can make an impulse because we don't know what the result here in Mexico of this impulse will be. That only time will tell, and the project will end in 2015, 2016. The fourth one is a kind of institutional arrangement between all these commissions, that we can make sure that they all have the same idea about this project, and also after this project are working in the same direction. So that there's only at the end one governmental product and not 4 or 5 different ones. And also the capacity building is an important part, because we are actually, with members of the United Nations, more international colleagues. And at the end of the project, the goal is that the United Nations gives the whole result to the Mexican partners of the project, that they can use these things. So for that we need to make a kind of capacity building. So So I want to talk a little bit today about the MRV system, the measurement, what was it? Yeah, this MRV system. The IPCC defines the elements of the MRV system as a kind of, oh wait, I nearly don't see it. I only want to make sure that I use the right words. The kind of, they need elements of activity data and of, right, here, of activity data and also of emission factors, which are here. That means, in fact, for an MRV system, we need a kind of land cover classification and also stock exchanges by carbon. To translate that now in our MRV system, we need at first a satellite forest monitoring system and also national forest inventories. Luckily, we already have a kind of forest monitoring system here in Mexico, which is done by INEGI. They published in the last, I would say, decade, several series of land cover and vegetation cover maps over whole Mexico with a scale from 1 to 250,000. And in addition, we want to use in the future, or already now for the project, satellite images of Landsat data and WebID data. So I would say we are one of these projects who have now an extended need for Landsat data, which are for free. And WebID data, okay, we have to buy. The national forest inventories are already existing also in Mexico. CONAFOR is providing several inventories since 2004, which are updated continuously. Every 4 years, I would say, they are going one time through all the country, and then they're starting again. And since 2013, CONAFOR also is getting a kind of inventories for different states. So the first one, this INFIS inventory, is for whole Mexico, and the other one, the IEF, is an Inventario Estadal Forestal, so for different states. About the legal framework of our project, in short words, CONAFOR has to report each year to the government a kind of a report about agriculture, forestry, and land use. That also means that they have to give a report about the degradation and deforestation in Mexico, about the whole country. And these classes they have to report are in the scheme of this INEGI series I mentioned. That leads to some question or to some definitions. For instance, what is a forest? By law in Mexico, a forest is a woody vegetation with at least 10% canopy density, with trees of a height of at least 5 meters and a patch size of at least half a hectare. Degradation is defined in Mexico as any decrease in a range from 100% canopy density down to 10%. When the canopy density decreases to less than 10%, that's par definition a deforestation. Another definitions of deforestation are a decrease of this forest to tree heights to less than 5 meters or to patch sizes less than half a hectare. And this land use change has to be constant for several kind of years that we still have to discuss how many years that have to be. Because, for instance, there also can be a fire, then a tree goes down, but it will regenerate. And then, by definition, it's not a deforestation, it's only a degradation. But we have still to discuss how long this land use change can be to be a deforestation. So we want now to implement a program to calculate the land cover automatically based on WebID data. From 2011 and 2012, we already have WebID data. We are now negotiating for 2013. And our plan is within 6 months, we normally want to calculate from the satellite images for whole Mexico the land cover classes. 3 more months we need then for quality control with the help of expert knowledge of Mexican colleagues and also different other data. 2 more months we want to use for then a kind of internal review to see different regions of Mexico with maybe a less quality, with less quality. And after that, we need 1 more month for an official publication as a governmental product. So our goal is to have the first pilot product at the December of 2013 and to have this whole workflow operational in 2014. This is now only for the RapidEye data. In addition, we also are implementing a historical baseline based on Landsat data. Only a short data of this product we want to have. We want to calculate a land cover product based on 26 classes, which are defined by INEGI classes. Also, we want to calculate or implement a land cover change product. We still have to discuss how many classes this can have. We are calculating a forest non-forest map. This is derived by the land cover classes. And we are calculating a forest canopy density map for whole Mexico. But that we are not doing here in Mexico. This is doing Professor Matt Hansen from the University of Maryland. So the mapping scale of these things is because it's a Landsat data, it's 1 to 100,000. It's much better already than the INEGI series with 1 to 250,000. And we are actually implementing and calculating now informations for the whole country of the years 1993, 95, 97, 2000, 2002, 2005, and 2008. This is actually happening. We are doing it partially with our servers in Conavio here in Mexico, and the maps for the years from 2000 until 2008, we were kind of exporting to the MRED project of the USA, which is done now in the somewhere in Boston. Pardon. So as I said, that is already working. This is our workflow. It's looking a kind of technical, but in fact, it's not really difficult. Actually, at first we use for each year we want to calculate. We are getting all the Landsat data we have in one archive, and we only want to use the Landsat data that have a cloud coverage of less than 10%. Here you see a map of Mexico with all the amounts of Landsat data which are available for different tiles. As you see here in the north, we have much more Landsat data available than in the south. That is only because in the south we have much more clouds. In the northern part, this is a desert region here in Mexico. Where is it? There. It's a desert region. There we have much more information. And because we have this different amount of information, we cannot calculate one whole map in one step of whole Mexico. Instead of that, we have to calculate them tile-based, only because we have different kind of information for each tile. So now when we want to calculate now for one tile, one of these classifications, we are getting from our archive automatically at first all the tiles which are of these, all the info. We get all the images of these tiles. And at first we have a kind of pre-processing that means at first an atmospheric correction. We want to mask out classes like water, like snow, because on this early time of the workflow, it's much easier to get these classes out with a high accuracy, but also we are masking out the clouds, the shadows of the clouds, because we cannot use this information for our classification process. And when we masked out these atmospheric corrected informations, then we are implementing for one tile, for each images, we get for these tiles different vegetation indices like EVI, like NDVI, and whatever. And of these distinct vegetation indices, we are calculating now several time series for all of the images of one index. And for these time series, again, now we are implementing different matrices for each pixel. For instance, here the minimum value, the maximum value, the average for all images, for all image vegetation indices of one pixel. And based on these matrices now, we are implementing segmentation to get now some objects instead of the images, and now to calculate the statistics for these different objects. Based on these statistics now, which are again minimum value, mean value, maximum value of each of these segments, of each of these objects, we can now classify our landscape. For that we need training data, which we are getting from Inechi time series, from Inechi series again. We cannot use each of these polygons Inechi is giving us. Instead of that, we have at first to calculate a kind of clearance of these images by an outlier removal. For this outlier removal, we take the polygons of each Inechi of each Inechi polygons and calculate there at first a histogram for each class, and take now from these histograms the first 3 normal distributions, and each polygon of the Inechi class of the Inechi images which are outside of these 3 polygons we take away, because we cannot use it actually. We only want to have the kind of normal polygons. In addition, also we try to reduce all of the features we have actually by principal component analyzers, and we only take the first 3 highest features we have there. And based on these new features and on these cleaned Inechi classes, we now can calculate a classification. This classification this classification bases on a C5 decision tree. And yeah, as I said, we already implemented now several years. This is, for instance, an example of a year 2000 classification based on Landsat TM and ETM data. This has a scale of 1 to 100,000, and when we now put as a comparison the Inechi, original Inechi series next to it, we see, one time again, no, it's not going back. This is our ones, the new one, and this is the Inechi series. We see that our ones is more filigrane, it's more fine already. On the other hand, of course it's more fine because the Inechi series is 1 to 250,000. On the other hand, Inechi has much more classes which we cannot reproduce. We only can reproduce actually 26 classes, and Inechi series, depends on which series it is, has much more than 50. And we cannot reproduce it only with satellite data. Another example we have here, also of Mexico. This is here more in the south. This is the Gulf of Mexico. This is a Pacifico. Here's here somewhere on the wall would be Yucatan. This is again our program, our result. And as you, for instance, see here, this is only one class, and Inechi has exactly at the same point different other classes we cannot get. Now we can discuss are the images of Inechi correct, or is our result correct? We also can maybe say it can be that for this year we only have information in this region of maybe January, and Inechi is saying that they have it for whole the year. Maybe the change of the class was coming after we had our images. We don't know. So these are things we still have to discuss in the end. So as I said, we calculated these things already for several years. We need for one whole calculation for Mexico 4 days actually with the servers of Conavio, but we also are planning to distribute not only the results but also the chance to recalculate these things to different commissions like Inechi, like CONAFOR, and so on, and that we are doing actually with the help of Google Earth Engine. Google Earth Engine is a kind of Google Maps, Google Earth, where also a programming tool is included. So, and then we can use the whole infrastructure of Google that will go much faster than our small server in Conavio. So here I have an example of, again, one Landsat tile. This is the original Landsat tile. We are calculating here now a vegetation indices of all the images of this one tile with the help of Google Earth Engine. We are calculating after that the the matrices of this. This is now a force color image. These are the minimum, maximum, mean values for each pixel of the different EVI values. After that, we are defining some kind of persistent areas that we can use as training data. This is, for instance, Guadalajara, only, but as a training data. And with these training data, now we can calculate a classification result. And for the whole baseline, also for one country, for 1 year, we only need less than 30 minutes with the help of Google to calculate the whole classification process, which is, I think, a nice thing. Another topic now, we are also implementing now not only the baseline, but also the years now with the help of WebAI, as I already said. This is helping much for the constraint that oh no, this is okay, that I will go. I don't have the time anymore. This is, helps much for the constraint that we have to get patch sizes of half a hectare. Here we are. WebAI, for instance, when we now compare it, a Landsat image, this is a minimum mapped unity of half a hectare, and half a hectare of a Landsat image only have a little bit more than 4 pixels, and for these we cannot really calculate statistics like standard deviation and so on. And for that we are using now WebAI data, which have a pixel size of 5 times 5 meters. WebAI has 30 times 30 meters, and there we can use much more pixels, and so much statistics with a much higher accuracy. So okay, the workflow is more or less the same. We are actually still working on the first results. I heard half an hour ago we had the first results, so it was too late for getting it in here. I have not seen it until now, but I heard it's a really good first result already. But also, in addition, we are not only implementing it with Conabia, we are also implementing this at the same time with Google Earth Engine. And until now, we are until the segmentation process, so we are not calculating until now, not the statistics and the classification itself. That still needs time until we are finished with that. But we also can see here already the segmentation process is really well. Here we can see the rivers, for instance, perfectly already. Also the seas here are definitely well done. And this is much faster than when we are doing it only with Conabio, because when we would calculate the whole process in Conabio, it would need months for one country. Another topic we are already starting now is a land cover change. As I already said, this is also a goal we have. These are only first ideas, first results to prove that we can do it in theory. Here we have a WebAI image in this moment. It's a force color image. The near infrared is here in red, so that means the high vegetation regions are here red. And when we put now another image on it, then we see, especially next to this river, which is here somewhere, this one, next to the river there are several changes, and we can already detect it more or less automatically. And that we are doing here is as an example of an image detail. We are doing we are putting one image and another image together, and we will see when I put the other image that here are several differences. As we have seen here, for instance, there was earlier it was forest, now it's a kind of bare soil. Here, this one is also a change, but it's not it's only a degradation, it's not a deforestation. It's a kind of, before that it was a kind of agriculture, it was cropland with the plants, and now it's the same cropland, but the plants are cutted already, so it looks different, but it's in fact still grass. And now we have to divide these both changes. One is a real change, the other is not a change. It's only because an inner annual timeline. And to detect now really this change, we have actually still to define manually absence and existence of changes. We say, for instance, this is a change, this is a change, this is no change. And based on these training data, we can have more or less the same approach again, like in the land cover workflow. We are segmenting it. We have now the training data. We have vegetation indices and so on. And there we are getting the this is the last slide. There we are getting, this is our first results. So we already getting the information, this yes is a change, this is a change, this is no change. Here are other different ones which are also changed, but officially it's no change, and so on. So we still have to work on that. And the project ends on 2014, and we hope that we made all of it until then. Yeah, thank you for your attention.
Gracias, doctor Schramm. Tenemos tiempo para un par de preguntas. Por favor.
Buenas tardes, vengo de parte del Ministerio del Ambiente del Ecuador. Primero, muchas gracias por permitirme estar aquí y la exposición ha sido excelente. Hace algún tiempo los geógrafos anteriores hablaban de que existe dos clases de geógrafos, el geógrafo de gabinete y el geógrafo de campo. Últimamente se ha estado tratando de integrar estas dos para ser un geógrafo muy integral. Quisiera saber si es que dentro de la planificación de tu proyecto tienen una campaña de verificación en campo para hacer que tu mapa sea mucho más real, veraz y verificando los reales cambios de cobertura vegetal.
This is a large problem here in this project. We have to believe that the training data we are using, which are taken by the INEGI series or also by the INFIS data set of CONA4, that they are true. We are already knowing that they are not true all the time. And exactly for that, for instance, we were implementing these kind of outlier analyzers we had, because not only because of the diversity of the segments we got from INEGI, also because we are thinking that these segments are not all the time the correct defined class. For instance, you have seen one of these images of the results, of the classification results in the south of Mexico, where I was saying that INEGI had their one spot, one patch with a different class. We can now believe that it's because of different times. We can believe that it's a kind of quality lag of the final result we are calculating. We also can believe that there was one colleague of who was there and checking the class, that he was maybe on the wrong spot, that he only had another idea of what is a class, what is not a class, and so on. And we still have to believe that most of the training data we get are true. That's the only chance we have, and I think that will also be the only chance you have.
Gracias. Tenemos tiempo para una pregunta muy corta.
You are talking about all Mexico, but have you targeted any state like Michoacán, Durango, or any state that they have a lot of trees in this case? And to say, this year we have, I don't know, maybe 20 acres, and next year these acres they reduce to 10 acres, and say, this to say to the government, you have a real deforestation in this part of the Mexico or something like that one. I mean, have you tried to go with a small one? For example, with Michoacán, right now there are a lot of deforestation. To say, this is how many feet cubic of wood is, there is in the black market or something like that one. I mean.
So, yes, so it was a long time negotiation with the government to define these laws I was showing you. It was already, these negotiations were already beginning before the project started, and I don't think that it's already really ended. So each time someone is coming and saying, but we still have to define another type of deforestation, degradation. Each country in Latin America has a different law about these things. I was only showing here you one part of the whole project we have for the greenhouse gas inventory. Another part is not the satellite images, another part is then really this carbon stock exchange. So that means that other people, other parts of the project are now defining based on our new classes, on our degradation maps, for instance, what really happened and how many carbon now is going. And this is the final really important product. And I think with this product, also your question can be answered, because when we have at first a patch, a forest of 25 hectares, and after that a forest of 10 hectares, then we don't have it in our deforestation map, because per definition it's not a deforestation, but we have it in our degradation map. And then also the other part of the project can come and see, okay, there's a degradation. This degradation is defined as from 25 hectare to 10 hectare, and what does that mean with our carbon stack? So the result will be the same at the end.
Gracias. El tiempo se nos acaba. De todas maneras, tanto Matthias como Barbara Ryan seguramente podrán platicar con ustedes en este receso. Solo me resta, por parte del comité organizador, entregarles unos pequeños presentes, agradeciéndoles mucho su presentación, por favor.